Hello, this is week 8 or something, CS 111. Today we're going to be looking at something called lists. Most languages you might hear something called arrays or associative arrays or vectors or any of those things. Lists in Python kind of covers all of that. So everything we've had previously, we've looked at strings, floats, integers, booleans, and we had something that was equal to something, right? And in every case there was in every one of these cases we have one variable to one piece of data. So kind of the big difference when we get into lists is that we can now store multiple pieces of data and associate it with one variable name. So that kind of looks like this, and we use these square brackets, and within the square brackets we separate our data with a comma. So here, if I were to write this, A is now 1, 2, 3, and 4, as opposed to just being 1 or 2 or 3 or 4. It is now all of that. So if I print A, if I save this and run it, you'll see that we get this list 1, 2, 3, and 4. Now, we can do it with all types of data, right? I could do 1.0, 2.0, 3.0, and 4.0. Run that. Right? We're getting 1.0, 2.0, 3.0, 4.0. We could use strings, we could use booleans, right? Any type of data works in a list. If you have a background in C or C++ or something, one of the things that you might note is that a list, in those languages can only have one type of data. Whereas in Python, it can actually have, all these things at once without a problem. You can have a space, it doesn't make a difference. We can have 1.0 as a float, 2 as an integer, 3 as a string, and false as a boolean, and store them all within the same list. It doesn't matter, and that's something that's kind of unique to lists, in that it can store multiple types of data in one, basically, data type. Right? This data type is a list, yet it's storing all other types of data. So that's something that's kind of unique to lists in Python. And it's really cool. It can be really beneficial. On top of that, lists, arrays, let's say, in other languages, are often initiated by saying something like, say we want to use like Java, right? If we were using some Java, we'd be saying, okay, we got this variable A, it's equal to a new array of 5 elements, right? It can store 5 things within this array. And you have to set the length of the list, the array, prior to adding data to it. And it's the same in C-based languages, that you create a list that has a set length. And it has to do with how much memory is used to store the data when it's created. When I create this thing, how much memory do I need to store A? Well, it can only be determined if you know the length of A. Well, in Python, you don't need to actually do that. I can create a blank list and then use the append function to add data to it later on and allow the list to change size dynamically based on the amount of elements within it, which is pretty cool if you've ever used a language that didn't allow you to do that. When you hear about the website Stack Overflow, right? StackOverflow.com. It's where you get like a lot of, if you look up stuff on the internet in regards to coding, Stack Overflow is where you'll find a lot of stuff. a stack overflow is actually an error that you'll get in languages that don't allow you to change the size of a list of an array. And it's actually in reference to if I have a list or whatever, right? If I have and it holds 5 things and I try to add 6 things to it, say it's already got, right? So A is equal, we'll write some funky code here. Okay, so that's 5 things. Say I now try to do something like this. That results in a stack overflow, meaning that you've added more data than it can hold. It's a common problem in lower level languages that you go over the length of the variable in terms of RAM. You try to use more RAM than is available to it. So Python eliminated that issue by just saying, no, our lists are going to be dynamic. It's what everyone's always wanted. Let's just use that. Okay, so at what point would you use a list? Why do you need a list? Well, one of the reasons is, when we've got something like this, we can, get rid of that by kind of storing everything together and then referencing the location in A to get out these values, as opposed to having 3 variables and kind of forgetting where things are going. It might, make more sense to just use a list. You can also have, kind of lists of lists. And this is kind of where it gets tricky. So here we have a list that has 3 elements in it called A, right? The first element is a list with 3 things in it. The second is another list, 3 things in it. Apparently I've used the wrong numbers here. Let's see if I can do that properly. Alright, 1 to 9. And then the third thing is another list inside there. So if we run this and we say print A, we get the same thing back. What I mean by positions, right? This is at position 0 within a list. This is at position 1 within a list, and this is at position 2. So if I were to say print A at position 0, we just get back this first list. I could actually do a double reference here because we have a list within a list. And I could say, give me position 0, 0, which is 1. So this allows you to kind of reference, based on positions, things within the list. So you just, the syntax here is you use the name of the list, A in this case, then a square bracket, and then the position that you want to print starting from 0. So this is element 0, this is element 1, this is element 2. So if I say give me element 2, you'll see I get 7, 8, 9. And because that is also a list, I could say, here's position 0, position 1, position 2 within this little list. So I could say give me 2, 2 and get 9 back. I do. I could say give me 2, 0 and get 7 back. So on and so forth, right? We could put as many lists as we want down inside of these other lists. And these are called multi-dimensional lists or multi-dimensional arrays in other languages. We don't really care about that right now. We're kind of working on the simple things. So here we've got 1 to 5. 1 is at position 0. So if I want to print that 5 is actually at position 4. So if I run this and print it, it's going to give me 5 back. Because positions start from 0. Okay, so along with that, lists have some functions that can be ran on them. We can run, a max across a list. Max is 5. We can run an average across a list. Oh, maybe I have to get that from math. Let's see if I can get it. I cannot. Alright. Well, there is an average function. I'd have to look it up in the API. Sorry. Thought I knew it off the top of my head. We can run we can run a sum function. So the sum of 1, 2, 3, 4, and 5 is 15. Let's see if we can run a min function. Minimum is 1. So the one we couldn't do was average, which there is an average function. Just look it up in the math library. Let's see, what else? What else can we do with lists? We can add things to a list. So I've got 1, 2, 3, 4, and 5. I'm going to append 6 and print A. You'll see 6 got added on there at the end. So when you use append, it adds to the end. If I put 0 in here, it's still going to go at the end. The positions are an actual thing. So I could append that, and then what if I wanted 0 to be at the beginning? Well, I could sort A. Then 0 moves to the beginning. It's sorted. Let's see, what else can we do? We can remove. And the way that the remove function works is that given the value, if it finds it, it will remove it. So if I say 3, right, it's not position 3, it's the value of 3, and it will remove the value of 3. So it removed it. And we can prove that. So we had, our list looked like this. So 3 was actually at position 3. So that wasn't a very good example. All these numbers are actually at them. So let's get rid of that 0. 3 is now at position 2. So if we say remove 3, it should still remove 3. And it did. It removes the value, not the position. Okay, so if you wanted to remove the position, we can use this other function called pop, and it will remove the position rather than the value. If we just use pop by itself, it'll just remove the last thing in the list. So in this case, we're going to get rid of 4 and 5. Pop also returns the value to you, so we could set x equal to a.pop and print x, and we're going to have the list and then 5. So it returns the value. So you could save it in another variable like that. Remove does not do that. Remove simply removes it. Let's see. So we can search a list as well. I could say if 4 is in A, print 4 is in A. Okay, so it found it. 4 is in A. What if we search for something that's not in A? Nothing happens. So that's simple if whatever in whatever the list name is, right? It doesn't get any simpler than that. It's basically English. You're asking the computer a question. Is this thing in there? You've seen printing of lists. You just, print and then the list name. And you can give the position to print. Let's see. You might have to copy a list at some point, and this is really kind of the only thing in Python that is done with a little different way. So let me see if I can give you an example better than kind of talking this out, right? If x is equal to 5 and y is equal to x, and we print x and we print y. Keep forgetting my parentheses. Okay, so we print x and we print y. We get 5 and 5, right? If I then change x and x becomes 10, did y change just because it was linked to x? No, it did not. Y is still 5. Okay, so this is a value. This is a reference to a value. And this is a new value. Okay, so this is referencing the value that's stored here. Does that make sense? If, however, it didn't reference it, and it instead pointed to x in terms of how memory works, it would be a pointer. So there's reference values and pointer values. Well, for whatever reason, the way that lists work is that they are done by pointers. Okay, so it's just pointing. Now when I say b equals a, if I print a and I print b, you'll see that they are the same. Let me clear my screen here. Maybe. Alright, and I run that. You see they're the same. But if I now change a in some way, and I now print a and b, you're going to see that they're still the same. Right? B also lost the 5. Because it's pointing to the list rather than the values themselves. It doesn't reference the values, it points simply to whatever A is storing. It doesn't create a copy. So if we want to create a copy, we can do that by saying it equals A from start to finish, and it'll create a copy. So we can prove that by popping off of A, 5 is gone, but it still exists in B because we've created a copy as opposed to just a pointer to the values. So that's kind of the one place in Python that things are done a little differently than in other cases. All right, last thing here, if you want to loop over a list, we can say A is equal to 1, 2, 3, 4, 5 for x in A, print x, and let's see what we get. Remember these parentheses, I'll be a much better coder. Alright, we get 1, 2, 3, 4, and 5. So x became 1, then it became 2, then it became 3, then it became 4, then it became 5. We've seen that already when we use the range function. It has the same thing going on. Okay, so we can do this as well. We can use this, we can say for index and value, and you can call those whatever you like. And we can use this enumerate function on A, which is going to give back 2 things called a tuple. And we can say print the index and the value. And you'll notice the index here is 0, 1, 2, 3, 4, where the value is 1 to 5, right? These values could be anything. They could be 5, 10, 15, 20, 25. The index isn't going to change, 0, 1, 2, 3, and 4. The value, however, do change based on what's in it. So if you need to know the index and the value, you can use this enumerate function. If you only need the index, you can use for index in the range length of A. You can print the index. And I'll show you kind of, dang, these darn parentheses. So not used to Python 3. Okay, so here it is, just the indexes, 0 to 4. And the way that this works is, let me comment some of these prints out here. So the length function will tell us the length here. That's what I forgot. Yep. Okay, so the length of this thing is 5. Length is 5. How many indexes are there? There's 5, right? 0, 1, 2, 3, and 4. That's 5 if you're counting. There's 5 things in there. The indexes are 0, 1, 2, 3, and 4. So if we then use the range function, we're basically saying for index in range 5, which we already know what that'll do. That will simply run 0 to 4. Right? We saw that last week. So those are kind of the ways that you can loop over lists. And that's really it when it comes to lists. So you're going to have some problems that you're going to need to use lists to solve. I don't know if you'll see copying or not, really printing. You'll see sorting, adding, removing, looping, all those things that we just saw. I'll add some notes to the page as well, so you'll be able to see them as you watch the video and not really have to, track all these things down. Next week is spring break, so there won't be any new things added. We got a little behind since I was sick. So when you get back from spring break, we're going to see custom functions. So next week, spring break, following custom functions, and then after that we'll have the midterm. Got to get to custom functions before we can really do the midterm. And custom functions is just kind of a way to better reuse your code, to kind of name sections of your code. So we'll see that, and then we'll have the midterm. And that's really, the custom functions are kind of the last big must-have that we have to get through in this course. So then after that, we're kind of open to, some more advanced things, some new things that, it's kind of, we've got a couple weeks there where we can just kind of test things out and see, if there's something you're interested in learning, go ahead and, shoot me an email, because we're going to have some open weeks there. I put down some things initially on the syllabus. It doesn't mean we have to use them or have to get to them or any of that. The custom functions are really the last big thing that we need to cover in this course. So even though we missed a little bit of time there, we're still right on track for getting through all the material that we need to cover here. All right, so that's all. Thanks.